Hello everyone, I'm Ryan Zhao, and this is my groupmate Chinxuanhong. We are tasked as land engineer by BAIT2004, a new manufacturing company. We have been asked to design and set up local area networks for the company in different locations in Kuching, Sarawak. We have location A, administration department, has 50 hosts. Location B, comprising 80 hosts. Human resource department with 6 hosts. Accounting department with 60 hosts. Location C, sales department. There are 3 rooms with 3 laptops and 1 network printer each. In location D, warehouse department, there are 20 end devices and 4 network printers. We are also required to design, configure, and test the addressing scheme for the company that is fulfilling the above requirements. In this project, our task is to design and build a LAN for Palm Brunei Berhad. To achieve this, we utilize VLSM over FLSM, as it offers the ability to create subnets with varying sizes and host numbers. Unlike FLSM, which can only create subnets with the same size and host identifiers, VLSM minimizes waste and avoids excessive usable host addresses. Palm Brunei Berhad requires us to establish a LAN that covers 4 locations, which is A, B, C, and D. Therefore, we will employ VLSM to divide these 4 locations into 5 subnets, ensuring each subnet is tailored to its respective location's required number of hosts. First, we partition the 4 locations A, B, C, D into 5 subnets and split location B into subnets covering its first and second floors. We had 2 main rationales for dividing location B in its manner. Firstly, human resources and account departments belong to the administrative management department, while the manufacturing department is part of the manufacturing and production division. By segregating them, we enable administrators to implement more targeted security policies and restrict communication between unrelated departments, thus reducing the risk of data breaches and other security threats. Secondly, given that Palm Brunei Berhad is a manufacturing company, we anticipated that the manufacturing department would see significant employee growth. By designing separate subnets for each department, we minimize network congestion, improve transmission efficiency, and lower the potential for security issues. The manufacturing department would see significant employee growth. By designing separate subnets for each department, we minimize network congestion, improve transmission efficiency, and lower the potential for security issues. We started by arranging 5 subnets in descending order of required hosts, as follows: Subnet 1, manufacturing department, requiring of 80 hosts; Subnet 2, administration department, requiring a total of 50 hosts; Subnet 3, warehouse department, requiring a total of 24 hosts; Subnet 4, account and human resources departments, requiring the total of 22 hosts; and Subnet 5, sales department, which we need of 12 hosts.
Okay, so my name is Chinxuanhong, and this is the calculation table, and this table will show the refactor in a 30% increase in the number of address required for the largest and the second largest subnets per the specification provided by Palm Borneo Berhad. Okay. Accordingly, the new total host for subnet 1 was 104, but the new total host of subnet 2 was 65. So as the combined number of hosts across these 5 subnets is the maximum allowed by Class C address, which is 254 hosts. So we decided to employ a Class B subnet mask 255.255.0.0 as the default subnet mask for this project. And this is the VSM table, which will show the subnet, the usable host needed, total IP, and some details. So in this project, we use the Cisco 2960 model switch. This process 24 fast Ethernet port and 2 gigabit Ethernet port. For subnet 1, the original host needed was 104, so we divide 104 by the 24 as the fast Ethernet port. So the value is the 5, and the result need to add 1 more because we designed it use a message in the subnet. So the total result is 110 hosts, and the second subnet the result is 69 hosts, and the third subnet result is 26 hosts, and the fourth subnet result is 34, and the fifth subnet is 10 hosts. And this is the IP addressing sample. It will show the subnet and the network address, broadcast address, the first usable host, and the last usable host. So in this project, which the Cisco 2960 switch model for the because the outstanding feature, this model boasts a longer mean time between the failure, ensuring a reliable network operation and provide advanced security feature that resists access and reduce potential threat. Furthermore, we opted for the router empty model, which offers a customizable gigabit Ethernet port that can be tailored to the specific number of subnet required for our project. So we customize the router with 5 gigabit Ethernet ports to seamlessly connect each subnet while also taking measures to cover the remaining port to prevent the dust and other impurities from ensuring optimal performance and longevity. So in addition, we employ 2 types of copper cable to establish reliable connections between end device switch and the router. So this includes the use of crossover table to interconnect the switch and the track-through cable. So adhering to commonly used from entering the router's interior T568 and B standard in Malaysia to connect PCs and switch as well as router and switch. So this meticulous approach in selecting and implementing the appropriate cable ensure efficient and secure communication within the network. So this is the addressing table. It will show the device and the interface, the IPv4 address, subnet mask, and the default gateway. So here is our network topology. So the figure 1.0 is the overall network topology showing a router consisting of 5 LAN for each 5 different locations, which are location A, location B, ground floor, location B is first floor, location C, and location D. So the network address for subnet 1 is the white color is 172.16.0.0. So the subnet 2, 172.16.0.128. The subnet 3, the gray color one is 172.16. Ivory color is 0.1.0, and the subnet 4 green color which is 172.16.1.32. And subnet 5, the purple color one is 172.16.1.64. So the router is connected to 5 switch located in 5 different locations through the copper straight through cable. Okay, so this is a figure 1.1. So in this 1.1 network address is 172.16.0.0, and the subnet mask for this subnet is 255.255.255.128. So we can consider that the subnet 1 require the most hosts. So we provide more PC and the switcher for as example for this subnet, which is the 4 switch and the 6 PC. And for this, the first subnet, we assign the router's IPv4 and the default gateway IP to the first usable host address for this subnet, which is 172.16.0.1. Then this is the figure 1.2. The second subnet network address is the 174.16.0.128, and the subnet mask is 255.255.255.128. So we use the 3 switch and the 4 PC as an example. So in this subnet subnet, we assign the router IP before and default gateway IP to the first usable host address for this subnet, which is 172.16.0.129. And this figure 1.3. In this, the third subnet network address is 172.16.1.0, and the subnet mask is 255.255.255.224. So in this scenario, we use 2 switch and 2 PC as an example, and the router address is assigned with the 172.16.1.1, and this is also the default gateway for this subnet. In the figure 1.4, which is the fourth subnet, so the network address for this is the 172.16.1.32, and the subnet mask is 255.255.255.224. So in this, we use the 3 switch and 4 PC as the example for different department. In this subnet, we use the first usable host address as the default gateway and the router IP, which is 172.16.1.33. So in this, the figure 1.5, subnet 5, we use the network address is 172.16.1.64, and the subnet mask is 255.255.255.224. We use 4 switch, 3 printers, and 9 laptops as the example of the subnet 5. In this scenario, we separate 3 switch for the example of 3 different rooms, and we assign the router's IP before and the gateway IP to the first usable host address of this subnet, which is 172.16.1.65. We then assign the IP address of each device by following the subnet usable host address, which is 172.16.1.66 until the 172.16.1.94. And then this is for the network configuration. So now I will show the network configuration. So now I will show you router configuration. So first is the Cisco password, enable the secret class. Then show run align console 0 password and Cisco and encrypted password and login AX0 and password encrypted as the Cisco and login virtual terminal 04, virtual terminal 5 and 15. So this is all the IP that we assign for each interface, which the gigabit the net 0/0, 1/0, 2/0, 3/0, and 4/0, which is 1, 2, 3, 4, 5. So up here we enable the password. This is Cisco, and the secret is a class. And because the service password encryption, so we can't see the password. Okay, so now I will show you how to assign the IP and configure the terminal for the switch. So the example we use is the switch number 7, the S7 in the first subnet, the first switch. So first we need to use the password Cisco and enable, and enter the secret in the class. So now we show the run. So this run will show us this. We already enable the secret, enable the password with the encrypt method, and the hostname is S7, and below that the IP address for this switch, which is assigned by the 172.16.0.2, and the default gateway is 172.16.0.1. So the banner we set for this to prove that this is a secure system, and then this we also add a password for the line console 0, the line virtual terminal 0 and 4, and the line virtual terminal 5 and 15. So the password is also the syscall, and then now I'll show how to configure the VLAN IP address. Configure terminal interface VLAN 1 IP address and 172.16.0.2, 255.255.224, and then now we need to go shutdown. So now exit and IP default gateway. So 2.16.0.1. So exit to show run. So we can show then basically same with the previous one. So I run configure start configure enter. So for the password, you just need to use the configure terminal and enable password Cisco and enable secret. And for the line console, it's line con 0, and we can come into the configure the line console password and exit. The same line virtual terminal. Send the virtual terminal 0 and 4. So this the how the configure the password. So that's all for the switch. And this for the devices. We like the PC we use the desktop IP configuration, and then we add all the IP address of the mask default gateway, and that's all. Then for the printer, we use the config the fast Ethernet 0, and then we set the IPv4 and the subnet mask. And this is the default gateway. That's all. So now I will show you how to ping the different subnet and device. So example, we open PC0 and the command prompt, and then we ping this is a second subnet. So we ping the first subnet device, which the ping is 172.16.0.60, the PC8. So it's successful. And now we use the PC14, lets us to ping the pin 172.16.0.135 in the PC2 in the subnet, the second subnet. So it's successful and not packet losing. And now, for example, use the laptop 7. So it's same command ping 172.16.1.9. Is the fourth subnet, the PC8. So no problem. And now we use the first subnet PC8 to ping the printer 1, which is ping 172.16.1.80. It's successful. So this is the example of the ping. Okay, so that's all for our presentation. Thank you.